So we now have some time for question and answer. And I've got a list of questions here from the chat. If there's any other questions, please feel free to post them. And the first question I have on this list is for Jack. The question is, Jack, did your tools work well for shallow trenching to expose stratigraphy? You succeeded in obtaining a 3D view of the orange glass deposit, but would a different tool have made it easier or better? And I'd like to invite all of our speakers to come back on camera and join the conversation. So Jack, what are your thoughts about shallow trenching?
Well, trenching is sort of a misnomer. What I did successfully and very usefully, I think, is a half trench, using the scoop to dig a wall rather than a trench. And the procedure that I used was always to have that wall more or less facing the sun, so that you got full basically direct sunlight image during the photography. And a good illustration of that, of course, is the trench across the orange soil ellipse that I noticed at Shorty Crater. But you can let me just amplify that a little bit. In spite of the incompressibility of the static regolith, you can dig into it if you think of it in terms of just digging a wall. And particularly on a slope, it's easy because you throw the material behind you. But it's in 1/6 gravity. It's easy to get rid of the material that you're removing from that wall face. So I generally dug these trenches to about 20-25 centimeters. I think you could do more than that if you had the time, and if it was warranted by what you were seeing. It would have been nice if I'd had time at Shorty Crater to get that trench down more deeply, because underneath the orange material there was this black, partially devitrified ash. And you can see that now in the photographs. Some of it was exposed because of the slope. It turned out mostly to be noticed in the core that we obtained there. We had a 70-centimeter drop tube core in that deposit. But the trench was really very important for getting the initial geological context of what we were seeing, because I could trench totally across the ellipse and see the wall rock, in the geologic term, on either side. That so-called wall rock or wall soil turned out to be a very unusual regolith material, and I was able to get samples of both sides of that. The only sample that I missed in that wall or half trench was the material near the contact with the wall. We just ran out of time, and I did not get that material, and it visually was slightly more yellow than the orange material in general, and the core of the orange was actually red, more than orange. More than you needed to know, probably.
That's great stuff, Jack. Thank you. Next question I have here is for Ike, and the question is, what are your thoughts on swappable tools in a common architecture, something like a space Dremel?
Sure, thanks for whoever submitted that question. We have something very similar to that for the ISS right now. It's called the pistol grip tool, or PGT for short. So it's got a common 3/8 interface, much like you might have on a wrench in your garage. And we have sockets and all sorts of different tools that we can attach to it. It's worked very well for ISS, and we've used it on station. Well, it was designed and developed for Hubble, and then we've used it on space station ever since then. But if it makes sense and we can build one that works for lunar surface operations, we're all for it.
That sounds very interesting. The one thing that you have to be sure is that if it's a reusable connection, you have to keep the dust out of there, or have some method of making that dust irrelevant. In my recent time on reviewing the our ideas for Artemis tools about a month ago, they mentioned they had started to put a steel, call it a selvage, wherever you had moving parts, ground the regolith up rather than allowing it to be embedded in the aluminum. And that may well be a good solution. We'll have to keep looking at it, but I'm quite impressed with that idea.
There's a couple of comments and questions about drilling and coring. Let me just sort of highlight some of these comments, which is pretty interesting. So one is, has there been talk about using a dual rotary tool? And that's something that was used by this person at Oroville Dam. A small rig with this tool could be moved easily by hand. Another comment about coring and drilling was whether it could be used, the vibrations, for a secondary purpose. So perhaps to do some sort of seismic surveying in the subsurface. And then another comment, and this was from Pascal Lee, is there's some experience in drilling into ice-rich impact breccia deposits. And he found that using a rotopercussive drilling and drill tip shaving tool would be is optimal. So just want to pose the question to the whole panel. What are some thoughts on drilling technologies?
Well, I'll be happy to field that first. Of using a variety of multispectral seismic signals is a good one. In fact, it's been around for quite a while and used here on Earth to evaluate the integrity of runways and highways and things like that. And I think the initiator of that multispectral seismic sensing was at University of Texas, and it is commercially available. It's done. I don't know what you would say its TRL is, but we proposed it 25 years ago in the first discovery round, and planned to use a subsatellite rover to provide the multispectral input. So I think that's a technology that has a lot of promise for evaluating the geotechnical properties of a resource area, a lunar resource area that might be excavated. The drive tubes worked very well. It did not take very long to get them in, with the exception of the orange soil. That was very highly compact. But withdrawing the drive tube never was a problem. So I think down to 70 centimeters, maybe as much as a meter, a drive tube works very well. You go more deeply than that, and I'm just not sure. Because of the incompressibility of the regolith, you'll not, if you're using a hammer rather than some kind of a driven post hole digger or that kind of thing, you probably will run into a problem of time if you try to go deep, sweep 70 centimeters, and generally without any great difficulty.
Right, thanks for that insight. Next question I have here. The next question I have here is for Oz. Someone mentioned whether there was multi or hyperspectral lidar available. Is that something that is on sort of the market? Is that something that you think would be useful for the moon?
Sure, that image I showed wasn't multispectral, but I think there are companies looking into it, and we've just finished up a contract where we were looking at, a three wavelength lidar for the moon, and you can do a lot more with those 3 wavelengths, and potentially picking out volatiles and things too. So, yeah, I don't know commercially available. Others may know more, but there's some in development at least.
Great, thanks. This next question I have is maybe something that Erica can field. How does one keep sampling equipment clean enough to reduce potential for contamination between successive samples?
Yeah, so for the 3 instruments that I showed, you can brush off if there's any kind of chunks of stuff on the windows, but a lot of them don't even have windows. They're just there's a little hole, and the detector is slightly off from that hole. So unless you have particles that are getting thrown up into that space, it's pretty clean between samples.
Great, thanks. And we got a little bit of time for, I guess, one more question. And I want to sort of field this broadly, but sort of aim it to Dean first. And I'm sure Jack will have something to say about this. Are there instances during the Apollo EVAs where having in situ analytical tools would have been beneficial or even transformative? There's a comment about the necessity of a geologist hammering an acid bottle. Would other tools like checking hardness, a streak plate, or maybe something more sophisticated in that, would that have been transformative?
Right off the top of my head, I can say no, but I haven't really thought about that in terms of, whether it worked. Again, it's the EVA time issue, and what's the minimum you need to characterize the site, get the samples collected and described, and move on to the next place. And no matter, if you look at the timelines, for instance, they had in many cases an hour at a site. And in many cases that wasn't enough. So it's really hard to say, but I don't think there was anything on Apollo that would have benefited from that. But Jack will have a better idea about that than I, if he's still here. I think we lost Jack.
We might have just lost him.
Yeah.
So Jack, if he can still hear us, what are your thoughts on whether having a particular instrument would have been really useful for you? Or maybe a better trenching tool?
If he's up, one of the problems we had was drilling deep holes, and we got a little better from 15 to 17, but putting holes down into the lunar surface was just really ugly, and not only getting it down, but even worse, getting it out. We lost the North Complex on Apollo 15 because it was decided that getting that 3-meter core out was more important than going to the North Complex. And in the process of getting it out of the ground, Scott injured his shoulder. I've read some papers recently that suggest that if we're really looking for volatiles at the South Pole, they're going to be deeper than 1 meter and maybe deeper than 3 or 4 meters. So getting deep holes in the ground is going to be really important, and we should never trivialize how hard that's going to be. By the same token, all of these instruments are designed and are used now in 1G 14.7 PSI atmosphere. And it's really hard to get something to work in vacuum, and it needs a lot of effort to space rate it. And so we can't start that too early in trying to decide. I mean, I made the comment in the chat that in '94, when I first started doing EVA work, they proudly showed me the prototype cuff checklist that they were going to fly on the first Hubble mission. And here we are 40 years later, 30 years later, and we still don't have an electronic checklist. Because the problem is getting it to be able to be used in the external environment of space. It's really hard.
Great. Well, I want to thank all of the panelists for this session. Again,